All right, welcome. We're going to be doing mole ratios. That's the lab. So the goal is to observe mole ratios in a simple reaction and also to observe the idea behind excess reagents and limiting reactants. So what we're going to need is we're going to need some calcium nitrate. That would be, oh wait, did I bring my calcium? Oh, there it is. Calcium nitrate and my lead nitrate. That would be right here. And then over here I have sodium oxalate and potassium iodide. I just grabbed the wrong stuff. All right. Sodium oxalate, potassium iodide. Now, what we're going to do is we're going to use column 1 in the 96 well reaction. So here's column 1, and here's A, B, C, D, E, F, G, and here's column 1, 2, 3, 4, 5, all the way up to 12. We're going to use only column 1, and we're also only going to use only column 12, just so that way we don't mix things up. Now the experiment says, okay, what we want to do is we want to put 1 drop of lead nitrate into column 1, A1. So we're going to do 1 drop in here, 2 drops in here, 3 drops in here, 4 drops in here, and 5 drops in here. And then when we add the potassium iodide, we're going to do it in reverse. 5, 4, 3, 2, 1. So that's pretty straightforward and simple. 1 drop here, 1, 2 drops here, 1, 2, 3 drops here, 1, 2, 3, 4 drops here, 1, 2, 3, 4, and then E1 gets 5 drops. 1, 2, 3, 4, 5. All right, cool. Now, for my potassium iodide, that would be this guy right here. Potassium iodide. Okay, and I'm going to go 5 in the first one. 1, 2, 3, 4, 5. And a note about how I'm dropping this. Let me see if I can get a close-up of this. A note about how I'm dropping this is I'm kind of going up a little bit higher. What I don't want to do is I don't want to drop it when it's touching this, because if it touches that, what happens is it will kind of it will break the surface tension of the drop, and then basically you'll get kind of half a drop. So in order to be consistent, what you're going to want to do is you're going to want to keep it high, but obviously you don't want to make it too high or else you're going to miss. So you got 1, 2, 3, 4. So you don't want this touching, but you also don't want it too high. Let me see if I can. Okay, I'm going to go 1, 2, 3 in C, 2 in D, and 1 in E. Now, there should be 6 drops in each. And if you look, yeah, they're pretty consistent as far as the height that they're at. Now, what we're going to want to do is we're going to want to fill in table 1 with the number of drops and of lead nitrate and potassium iodide in each well, and we're going to want to observe. We'll want to mix this thing with these little plastic toothpicks. A good lab technique is to always rinse with distilled water. I filled this thing up with distilled water. It'd probably be a good idea, and we don't say to do this, but I would highly recommend it. Is the first thing you should do is go out and go buy a big bottle of distilled water, and that way you and just have that on the side. Label it for lab experiment only, not for drinking, for chemistry only. And I'm going to rinse this off right there. So I just squirted that thing on there, and I'm going to use this to mix this up. And I use distilled water. Let's see. Yeah, we'll do it. Between each mix, I'm going to spray. I'm using distilled water, and I don't want to cross-contaminate my samples, so I'm spraying it each time. There. Okay, spray 4 and spray and 5. Okay, then let's spray this off. All right, let me move this camera so you can see it a little bit better. Yeah, that should help. Okay. All right, so what we're going to do is we're going to observe whether a precipitate has kind of settled at the bottom of these for each of these wells. Now, what I'm also going to do, and you're going to need to record this, what I'm also going to do is I'm going to show you part B, which is, I'm going to try another one. So I'm going to operate in column 12, and I'm going to only use A through E again. And this time I'm using calcium nitrate. Yeah, CaNO3, 2. All right, calcium nitrate. And I'm going to do the standard 1 on top, then 2 in the second one, then 3, 4, and 5. So that would be, okay, it goes 1 here, 2 here. This is a little bit harder because this is a clear liquid. 2, 3, 4 in D. 1, 2, 3, 4, 5 in E. 1, 2, 3, 4, 5. Awesome. And I'm going to put the reverse of the Na2C2O4. That would be sodium oxalate. So I'm going to go 5. Is it right? Yep, 5 in the first well. So A12 gets 5. 1, 2, 3, 4, 5. B12 gets 4. 1, 2, 3, 4. 1, 2, 3. 1, 2. And a measly 1. All right, so let's rinse these things off. Spray and steer. Oh, I see. It gets kind of nice. Spray and steer. Spray and steer. Spray and steer. Spray and steer. All right. Let me show you the results for part B. Let's see if I can show this to you real quick. I can't really. Whoa, and whoa. Hold on. 1 second. All right, here we go. Let's flip the camera around. Can we do that? No, we can't do that. Not while we're recording. All right, here we go. Can you see that? There we go. Okay. So it's hard for me to see whether or not what you can see. But what we're trying to do is we're trying to figure out whether a precipitate has formed. And what you're going to want to see if you see a precipitate is the original liquid that went in was clear. And now, obviously, you can see that each is quite murky. And so that murkiness is actually some kind of solid forming as this thing, as those two things react with each other. So that's what a precipitate is. All right. Once you do the tables and the lab write-up and answer all the questions, and then make sure that you take pictures of all the setup and everything, the most important part of the lab is always to clean up. Now, cleanup for this labs are pretty simple. Technically, you're not supposed to throw anything down the drain. However, in chemistry labs, you're not supposed to throw anything down the drain. However, these labs are designed to be at such a low concentration that you're able to throw it down the drain. Just make sure you use a lot of water when rinsing this stuff through. So I'm going to just kind of wash this off and wash that off and dump down the drain. There we go. So it's not too hazardous to anything. It's actually not hazardous at all to anything if at these concentrations. Now, if you had a higher molarity of these substances, then I'd have a problem with you guys dumping anything down the drain. And as long as you use lots of water, you can hear me, like how long I've been running this water for, just to make sure that it's well diluted. All right. Hopefully that helps. And let me know if you have any questions. Aloha.